Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am again back with another project, and which is a UPS design for the data centers. Well aware about that. I have already uploaded one video, and which is a UPS inverter design in MATLAB. So in which I have clearly explained all the requirement, how the UPS is working, what are the basic understanding for the UPS, how the system is working, how the block diagram of the UPS. So you can see here, the UPS is basically contain the rectifier, inverter, battery, the static bypass. This is the main supply and this is the load. Main supply is AC supply, AC converted into DC supply. DC will be used to charge our battery, and then this DC will be used to invert this DC supply into AC supply, and which will be used to feed our load requirement. And the static bypass switch is also there. So whenever any failure is there, any type of failure like a rectifier failure or inverter failure or even battery failure, at that condition, if you want to bypass this internal component, then you can just bypass by bypass static switch. It will directly bypass the internal component. Similarly, uh, the maintenance switch is also there. So when you wanted to work a maintenance activity inside the rectifier or inside the inverter or on the battery, at that condition you don't need to switch off entire UPS. You just bypass, you just press the bypass switch, and the entire power will be bypassed and fed to the load. So this is the basic concept I just covered over here. If you want a great understanding, I have already explained in this video. So first I request you to go to the check this video and then come back to this video. So this is the UPS that has been designed for the data centers. You can see I have considered the data center. You can see this image of the data center image. A 10 kilowatt three-phase load is considered, and 2 kilowatt single-phase load is also I have considered. So it's an unbalanced load. Obviously, there is an unbalance in the data centers or even any type of load. There is no balance in the load. So yes, I just run the model and will explain all the scenarios that is illustrated here. Okay, so back to our simulation. I have started the simulation. So you can see here the simulation is already in running mode, and right now the grid power is not failed. So you can intentionally fail the grid power by turning on this switch. So right now it is off condition. It means that grid power is not failed. So you can see the voltage which is nearly 400 volt. In between 400 to 450 volt we are getting from the three-phase supply from the Indian grid. Okay, so it is not a fixed voltage like a 450 volt and 440, not like that. Voltage is continuously varying. So yes, right now why this breaker is off, because I have on this bypass switch, but I don't want to use right now a bypass switch. So I just turning on this switch. So you can see the switch is on, and right now inverter come to the picture, then battery will charge, then again, okay, sorry, this is a rectifier is come to the picture, then it converted supply into DC supply, then DC supply is used to charge our battery, then the DC supply is again converted into AC supply to this inverter, and the filter is also there, and this is the dummy load for the stability purpose. Then we have to maintain the voltage, so voltage balance and the isolation transformer, and finally we are getting satisfactory voltage. You can see right now we are getting 390 voltage at our output side. So yes, uh, so right now everything is okay. Grid is also okay, and grid is feeding this much amount of ampere to our system. So this is a one UPS. This is a one UPS construction. So what actually happened? So whenever any grid is failed, so grid failure may be that can be happen anytime, you are not aware about that. So at same time, within a microsecond, UPS come to the picture, means battery come to the picture and tackle entire load. So there is no any variation in the load, not just a bit. So that's why we are using the UPS. And if we are not, then what happened? There is some interruption. There is some interruption in the power source. So data center in the data center, interruption is not desirable. If there is any type of interruption or any type of breakdown, that may cause a crores of losses. So that's why continuous power is very much important in the data center. And yes, so right now everything is okay. Battery is also getting charged. It takes some time to stabilize. And yes, so if I just turn on this switch, what will happen? I just turn on this switch, which represent that the grid is failed. Grid is failed means this breaker is off. So right now, what happened? Battery will come to the picture and feeding load. You can see amperes are there, slightly higher ampere because of the initially battery directly come to the picture, and entire load is on the battery. But here DG is also there. So DG takes some time. DG means diesel generator. Diesel generator takes some time to start. And once the diesel generator start, it will fade the load to the system, and then battery will getting charged. So the load on the battery may come for the 10 to 15 seconds, the time to start the DG. So after that time is elapsed 0.005 I have considered, because simulation is taking too much time to start. So after that time is elapsed, this DG will come, DG breaker will off, will gets on, this 0 will be a 1, and the entire load which previously was fading by the battery was totally transferred over the diesel generator. So if you want a construction of the diesel generator, I have designed it, and I have used a dummy load. It takes some time to reach voltage, and that's why I did not use that and just use another source of supply. But for representing over here, you can see diesel generator working satisfactorily. It takes some time to maintain some voltage level because we have just started the simulation, and this is a synchronous motor. This is a synchronous machine SI, and it's take, I think, 5 to 10 seconds to reach some satisfactory level, but we cannot wait that much amount of time. You can say simulation is already in running condition. We just reach at 0.023. Simulation is taking too much time because of the numbers of switching components is there. Inverter is there, rectifier is there, and that's why. So yes, so we will again create such situation in which we will fail the power, and we'll check how efficiently it is transferred over the DG. Okay, so I have started the simulation, and again you can see that uh, grid is okay. There is no failure in the grid power supply, and everything is working perfectly. At this condition, the battery is getting charged. You can see negative ampere. Negative ampere means battery is getting charged, when the positive ampere means battery is getting discharged. So, so obviously it is negative. That's why battery is getting charged. We have used 100 Ah battery as per our load requirement. You can change as per your requirement or dependent on the load condition. Even you can calculate the Ah capacity, obviously ampere hour capacity of the battery, because it depend on the load. So again right now, so yes, you can see, and if you want to check the voltage level and the voltage waveform that we are getting at the output side, you can see 415 voltage that we are getting. And if you want to check the waveform of the voltage and current, which is also very much clear, very much sine wave, the slight variation due to initial condition. So yes, we are getting very clear waveforms, and there is a voltage balance transformer that I have already explained. So right now I just created the situation in which I just turning on this switch. So as I turn on the switch, the grid failure is happen, and yes, you can see after slide of time, after some time, this breaker gets on, and once it's on, the battery will start getting again charged. So right now battery is getting discharged because there is no any supply source. Grid is also not there. DG yet not started. Take 10 to 15 seconds to start. Ideally, in industry, all the DG may take 10 to 15 seconds to start satisfactorily. So yes, you can see this positive ampere, and that clearly means that your battery is getting discharged. Okay, so you can see here after some times the DG is getting start. So yes, the DG is getting start as per the control logic. This breaker wave gets on, and you can see clearly initially the battery was getting discharged. Right now is also getting discharged, but it takes some time to stabilize. But you can see the DG started and it is feeding load through this UPS. And yes, okay. So this is how DG come to the picture and taking entire load over it. You can see battery getting reduced. It takes some time to stabilize. So you can see here right now negative ampere, which means battery is getting charged, and that is charged through DG. It's a DG supply. And yes, there is one static bypass which is also there. Whenever you require any maintenance activity over the rectifier or inverter, or if any type of failure happen inside the system, at that condition you need to bypass this UPS, and through this switch you can bypass it. So yes, this I turn on that switch, and as I turn on this switch, sorry, I turn on this switch, which totally isolated two breaker 1. This breaker is isolated, you can see 0, and this breaker is also isolated. Okay, so this entire system is now isolated. Entire UPS internal components are isolated, and you can work as per your requirement. You can do the maintenance activity, and the power must be continuous. So right now the power will flow through DG, through this bypass switch, and through this load. So you can see the voltage level also coming satisfactory. And right now if the grid come back, bypass switch is on, and if grid come back, grid power is come back. Okay, so what happen? If the grid power is come back, this will, the breaker will open, the DG breaker will close, and again come to the normal condition. It means it again come back over the grid. So right now grid is feeding power through bypass switch to our load. Okay, so this is how we have checked all the scenarios, all the possible scenario that is happening inside the uh, data centers, and this is how we can feed a continuous power to the data center. So yes, if you wanted to measure the voltage level at the output side, you can see we are getting perfectly constant voltage to our load. This is a slight variation due to the switching of this bypass switch, because bypass switching is not synchronized with our system. So whenever you bypass it, just bypass it, uh, and there is slight some spike. Okay. So this is how the power supply is continuously maintaining in the data centers. And hope you enjoy this video, and hope you learn something from this video. So thank you very much for watching this video. And if you have still any query, just comment it, I will definitely reply. And if you want this simulation, you can connect with me through my email ID or through my WhatsApp detail that is given in the description box. For any type of MATLAB project, you can connect with me with the same ID or same WhatsApp detail. Thank you very much for watching this video.